Good morning, dear students. So today we'll be starting a new lesson, that is Study of Compounds, Chapter 8A, Hydrogen Chloride. You are very much familiar with the compound hydrogen chloride. So hydrogen chloride, what is the molecular formula for hydrogen chloride? HCl. So this is the molecular formula for hydrogen chloride. And what is the molecular mass? 36.5. So why it is 36.5? Because mass of chlorine is 35.5 and mass of one hydrogen atom is 1. So if you add 35.5 plus 1, you will have 36.5. And the bond between hydrogen and chlorine is covalent bond. This you have already learned in class 9. So you can see here hydrogen and chlorine both are non-metals. So in non-metal and non-metal, the bond between non-metal and non-metal is always a covalent bond. The bond between hydrogen is a non-metal and non-metal. The bond between non-metal and a non-metal is a covalent bond. So the bond between hydrogen and chlorine is covalent bond. Hydrogen shares 1 electron and chlorine has 7 valence electron which it shares. So hydrogen shares 1 electron and chlorine shares 1 electron. As a result, they form a single covalent bond. So if you count valence electrons of chlorine now, then it is 8. 1, 2, 3, 4, 5, 6, 7 and 8. And for hydrogen it is 1 and 2. As a result, it forms a stable compound. So this is electron dot diagram of hydrogen chloride, and this is the covalent bond between hydrogen and chlorine. So you can see orbital diagram here. This pair of electron is the shared pair of electron. Cross shows the electron shared by hydrogen and dot shows the electron shared by chlorine. So you can see here chlorine has 1, 2 and this 8, 10. So altogether chlorine has 17 electrons, and with this shared electron it has 18. That means 8 in the outermost shell. And hydrogen has 2 in the outermost shell. As a result, this chlorine is also completing its octet and hydrogen is completing its duplet. As a result, it is forming a stable compound, hydrogen chloride. Then let's see how we prepare hydrogen chloride in lab. So lab preparation of hydrogen chloride gas. How we prepare hydrogen chloride gas in lab. It can be, so how we prepare? It can be prepared by the action of concentrated sulfuric acid on sodium chloride. That means how is hydrogen chloride gas prepared? Hydrogen chloride gas is prepared by reacting sodium chloride with concentrated sulfuric acid. So what are the reactants then? So you are very much familiar now. The reactants for preparing hydrogen chloride gas in laboratory are sodium chloride and concentrated sulfuric acid. So what are the reactants? Mind you, you need to learn these reactants. So what are the reactants? Sodium chloride and concentrated sulfuric acid are the reactants used for the preparation of hydrogen chloride gas. Then what is the procedure? Let's see. Set up the apparatus as shown in figure 8.1. So concentrated sulfuric acid. And now see here. First of all, in a round bottom flask or flat bottom flask, you can say any round bottom flask or flat bottom flask. Why you take a round bottom flask or a flat bottom flask? Because they can withstand high temperature. That means this flask can be used to heat at high temperature. So here we have to heat the mixture at a very high temperature. So first of all, we are taking sodium chloride or table salt in a round bottom flask, and then with the help of this thistle funnel thistle funnel we are putting concentrated sulfuric acid, and mind you, whenever we are preparing a gas, then the lower end of this thistle funnel need to be immersed inside the liquid, otherwise the gas which we are preparing will escape out from this thistle funnel. So the end of this thistle funnel has to be immersed inside the liquid, and this liquid is concentrated sulfuric acid. So what happens is the reaction proceeds slowly in the cold. That means, first of all, you are taking sodium chloride, and then you are mixing concentrated sulfuric acid through thistle funnel in that. Up to this time you have not supplied heat. So up to this you have not supplied heat. That means the reaction takes place slowly in the cold. And if you start heating, on heating the mixture gently, that means on heating the mixture gently, there is effervescence. Then that means when you start heating this mixture at a very high temperature, then there will be bubbles forming, effervescence. That means the bubbles, evolution of gas, the bubbles start forming, and this gas, is nothing but it is hydrogen chloride gas. So how do we prepare hydrogen chloride gas? By passing concentrated sulfuric acid on sodium chloride, and by heating the mixture we get hydrogen chloride gas. Then this hydrogen chloride gas which is formed is just passing through this delivery tube to this flask. And what is this flask called? This flask is washer bottle. What is this? Washer bottle. And in this washer bottle also what we have kept? In this washer bottle also we have kept concentrated sulfuric acid. So why we have kept concentrated sulfuric acid? Or you may ask one question, why we are passing the gas that is formed here to concentrated sulfuric acid again? Though it is formed from concentrated sulfuric acid only, then why we are passing this gas again to concentrated sulfuric acid only? So the reason is to make the gas dry. So in order to dry, the gas is dried. In order to get this dry hydrogen chloride gas, we are passing the gas evolved in this round bottom flask to this washer bottle which contains concentrated sulfuric acid. So here, that means the gas that is coming here, it may contain some moisture. But once it is passed through this concentrated sulfuric acid, the gas will be totally dry. So the dry gas goes from this washer bottle and it is collected in a jar. Then how it is collected? By the upward displacement of air. First of all, you can see here this jar is empty and all the empty vessels are filled with air. So once this dry hydrogen chloride gas is entering into the jar, then it will be occupying the lower portion of the jar. That means the air present in this lower portion of the jar need to move up, need to escape up, from upward direction. It escapes from upward direction. That means air will be moving upward. Hence it is called upward displacement of air. That means when hydrogen chloride gas is collected in the jar, the air moves up and escapes out. In this way, hydrogen chloride gas is prepared and it is collected. So let me repeat you again what we do. First of all, we keep sodium chloride or table salt in round bottom flask, and then we add concentrated sulfuric acid through thistle funnel, and then in the cold only the reaction starts slowly. Then when you start heating, the reaction takes place very fast and there will be evolution of gas, and the gas that is evolved is hydrogen chloride gas, but the gas is still moist. Moisture is there in the gas, and this moisture is dried by passing the gas through concentrated sulfuric acid kept in washer bottle, and through another end of the washer bottle the dry gas is collected in a jar by the upward displacement of air. That means it is understood that dry hydrogen chloride gas is heavier than air. It is not lighter but heavier than air. So it is heavier than air. So this is all about the preparation of hydrogen chloride gas. Then let's see what is the reaction that is actually taking place when this reaction takes place. When sodium chloride and concentrated sulfuric acid mix, then what chemical reaction takes place? Let's see. So NaCl, sodium chloride plus sulfuric acid, and you need to heat the mixture below 200 degrees Celsius. So what is the condition required? You need to heat the mixture below 200 degrees Celsius. That means you should not heat it above 200 degrees Celsius. I'll be telling you why we should not heat above 200 degrees Celsius. Okay, so for instance, you just remember that this mixture is to be heated below 200 degrees Celsius and will be getting sodium hydrogen sulfate. What it is? Sodium hydrogen sulfate, or in other words you can say sodium bisulfate or sodium hydrogen sulfate along with hydrogen chloride gas. So in this way we prepare hydrogen chloride gas. Though it is a reversible reaction, yet it goes to completion as hydrogen chloride continuously escapes as a gas. So this reaction actually is a reversible reaction, but then also the reaction completes. So why the reaction completes? It is because hydrogen chloride continuously escapes as a gas. So this hydrogen chloride, whatever is formed, will not remain with this sodium hydrogen sulfate. Okay, it escapes out. Otherwise, if it does not escape out, then it reacts with sodium hydrogen sulfate and forms sodium chloride and hydrogen sulfate again. But why the reaction continuously goes on? Why the reaction completes? The reaction completes because hydrogen chloride which is formed will not be there with sodium hydrogen sulfate, but it escapes out. As a result, the reaction will not be reversible. The reaction can occur up to the stage of formation of sodium sulfate on heating above 200 degrees Celsius. So the reaction can occur up to the stage of formation of sodium sulfate on heating above. That means if you heat the mixture above 200 degrees Celsius, then what you will get? If you heat the mixture above 200 degrees Celsius, then you will be getting sodium sulfate and hydrogen chloride gas. What you will be getting if you heat above 200 degrees Celsius? If you heat above 200 degrees Celsius, you will be getting sodium sulfate plus hydrogen chloride gas. Sodium sulfate plus hydrogen chloride gas. And then this reaction can be shown like this. Sodium chloride when mixed with concentrated sulfuric acid above 200 degrees Celsius, then the product will be sodium sulfate plus hydrogen chloride gas. Then why it is said that we need to heat it below 200 degrees Celsius? Below 200 degrees Celsius. Let's see. Now see here, sodium chloride is cheap and therefore it is preferred for preparation of hydrogen chloride over other metal chlorides. So why sodium chloride is kept? Why sodium chloride is kept? Why sodium chloride is chose to make hydrogen chloride gas? Because sodium chloride or table salt is the cheapest source. So is the cheap. It is available everywhere. It is available in the bank of in the seashores we get sodium chloride easily. So it is a cheap source. That's why we make hydrogen chloride gas from sodium chloride, and therefore it is preferred for preparation of hydrogen chloride over other metal chlorides. Then number 2, concentrated nitric acid is not used during the preparation of hydrogen chloride. So why we have not used concentrated nitric acid? Because it is volatile. Nitric acid is volatile and may volatilize out along with hydrogen chloride. Hydrogen chloride is also volatile and nitric acid is also volatile. So if we use nitric acid, then the mixture of hydrogen chloride and nitric acid may escape out in the form of gas. As a result, we cannot separate, we will not get hydrogen chloride, the pure hydrogen chloride, because there will be a mixture of nitric acid as well, because both nitric acid as well as hydrogen chloride are volatile and sulfuric acid is not volatile. That's why sulfuric acid is used in the preparation of hydrogen chloride gas. So why sulfuric acid is used? Because sulfuric acid is non-volatile acid. And why concentrated nitric acid is not used? Because concentrated nitric acid is volatile and it may volatilize out along with hydrogen chloride. And sodium chloride is used because it is very cheap. Then the reason for why we do not heat it above 200 degrees Celsius, it is because at higher temperature the apparatus which is made of glass may crack. So why we are not heating the mixture above 200 degrees Celsius? Because the apparatus which is made of glass may crack, and our intention is to get hydrogen chloride gas only. So if we can get hydrogen chloride gas, and if the reaction will be really very complete reaction takes place below 200 degrees Celsius, then why to waste fuel? So in order to save fuel also, we heat the mixture below 200 degrees Celsius. And then sodium sulfate forms a hard crust which sticks to the glass and it is difficult to remove. Again, sodium hydrogen sulfate does not stick to the glass, but sodium sulfate sticks to the glass and it is very difficult to remove this sodium sulfate. As a result of these three reasons, we do not heat the mixture above 200 degrees Celsius. That is there in the precaution section of the preparation of hydrogen chloride gas. So purification. Now, how do we purify hydrogen chloride gas? That is collected by the reaction between sodium chloride and concentrated sulfuric acid. So it is dried by passing through concentrated sulfuric acid, that is done in water bottle. The other drying agents like phosphorus pentoxide and quicklime cannot be used since they react with hydrogen chloride. Now, why? Again, the question may arise, why we are using concentrated sulfuric acid in order to dry the gas that is prepared? Because we cannot use other drying agents like phosphorus pentoxide and quicklime, because this phosphorus pentoxide and quicklime may react with hydrogen chloride gas formed to give different products. That is the reason why we are using concentrated sulfuric acid in order to allow the gas prepared to pass through, so that concentrated sulfuric acid do not react with hydrogen chloride gas and we get dried hydrogen chloride gas. So collection, number 1, hydrogen chloride gas is collected by the downward delivery, upward displacement of air, as it is 1.28 times heavier than air, So which is heavier, hydrogen chloride gas or air? Hydrogen chloride gas is heavier than air. That's why it is collected by the upward displacement of air. It is already discussed. It is not collected over water. Why it is not collected over water, or downward displacement of water or upward displacement of water? Because hydrogen chloride gas is highly soluble in water. That's why it is not collected by using water, but it is collected by the upward displacement of air. Then how to identify the gas? The gas collected in the jar is hydrogen chloride gas only. So how do we identify? How to identify the gas collected is hydrogen chloride gas only? Let's see. When When the jar is completely filled with hydrogen chloride, fumes appear above the jar's mouth. So if the jar is completely filled with hydrogen chloride, then what is the characteristic of hydrogen chloride gas? Fumes appear above the jar's mouth. Above the jar's mouth, you can see the fumes coming out. When hydrogen chloride gas is exposed to air, it gives white fumes due to the formation of hydrochloric acid undissolving in atmospheric water vapor. So what is the characteristic? How to identify the gas that is collected in the jar is hydrogen chloride gas? It can be known by the white fumes which is coming out, because when hydrogen chloride gas comes in contact with water or water vapor present in the atmosphere, then it forms hydrochloric acid. Because when hydrogen chloride gas mixes with water, it forms hydrochloric acid. Hydrogen chloride gas, when mixed with water, it forms hydrochloric acid. So hydrochloric acid. Then hydrochloric acid will have white fumes. As a result, we'll come to know that the gas collected in the jar is hydrogen chloride gas. In order to know whether the gas jar is full, bring a rod dipped in ammonium hydroxide near its mouth. HCl is there in the jar. Then you are bringing a rod dipped in ammonium hydroxide solution. Then you will be getting ammonium chloride plus water. That means, what is the characteristic of this reaction? Dense white fumes of ammonium chloride will be produced, proving thereby that the jar is full of hydrogen chloride gas. Now, how to prove that the jar contains hydrogen chloride gas? So this can be done by just opening the gas jar, and letting it allow to mix with air. Then we can see white fumes. Okay, this is number one way of identifying the gas. The other way, the very much reliable way to prove that the gas is hydrogen chloride gas is by bringing a rod dipped in ammonium hydroxide near its mouth. We see very dense white fumes of ammonium chloride, and then we can prove that the jar is full of hydrogen chloride gas. Then these are the precautions we need to take while preparing hydrogen chloride gas in the lab. The lower end of the Thiel funnel must be dipped in concentrated sulfuric acid. Why? Because otherwise, if you do not dip it in concentrated sulfuric acid, the gas formed may escape out through this Thiel funnel. Delivery tubes should be dipped in drying agent, that is concentrated sulfuric acid, in order to dry hydrogen chloride gas. And we cannot use other drying agent because the other drying agent may react with hydrogen chloride gas. And the temperature is to be maintained at nearly 200 degrees Celsius, and the region is mentioned out here, which I have already discussed. Then experiment to demonstrate density. That means to prove, this is the experiment to prove that hydrogen chloride gas is heavier than air. So how to prove that hydrogen chloride gas is heavier than air? It can be proved by pouring the gas in a jar with a burning candle as shown in figure 8.2. You can see here, this is the burning candle. The candle is burning, okay, the candle is burning, and you are pouring hydrogen chloride gas on this jar where there is burning candle. Then the candle gets extinguished because hydrogen chloride gas, being heavier, occupies the lower portion of the jar and forces the air out of it. So what happens is, if this burning candle extinguishes, then you can be sure that hydrogen chloride gas is heavier than air, because for the continuous burning of this candle we need oxygen, which is present in air. And if hydrogen chloride gas is heavier than air, then air escapes out. Once hydrogen chloride gas occupies the lower portion of the jar, air comes out, and once the air comes out, then the supply of oxygen is cut. So once the supply of oxygen is cut, this candle will not continuously burn, it extinguishes, which proves that hydrogen chloride gas is heavier than air. Other very much known fact is that we know that carbon dioxide gas is also heavier than air. So when we pass carbon dioxide gas, okay, through the burning candle which is kept inside the jar, then also this candle extinguishes, because carbon dioxide will be occupying the lower portion of the jar and air escapes out. Similar is the condition here. So if this candle does not extinguish, then you can be sure that air is heavier than hydrogen chloride gas. But if this extinguishes, then you can be sure that hydrogen chloride gas is heavier than air. So this experiment also proves that hydrogen chloride gas is neither combustible nor a supporter. Not only hydrogen chloride gas is heavier than air, but this also can be understood by this experiment that hydrogen chloride gas is neither combustible. That means it neither burns nor it helps in burning. Okay, neither it burns nor helps in burning. Hydrogen chloride gas neither helps in burning nor it burns. This also can be proved by this experiment. So how to prove that hydrogen chloride gas is heavier than air? Pass hydrogen chloride gas through the jar containing burning candle, and the burning candle extinguishes, because hydrogen chloride gas will be occupying the lower portion of the jar and air will be escaping out. Then experiment to demonstrate high solubility. So how to demonstrate that? How to demonstrate that hydrogen chloride gas is highly soluble in water? Highly soluble in water. The great solubility of the gas can be demonstrated by means of fountain experiment as illustrated below. So what happen is, take a dry round bottom flask. Take a dry round bottom flask filled with the dry HCl gas. So this round bottom flask, you can see here, this round bottom flask, okay, and this round bottom flask is to be filled with dry hydrogen chloride gas. Okay, is to be filled with dry hydrogen chloride gas. Then arrange the apparatus shown in this figure. Arrange the apparatus shown in this figure. Then on the mouth of the flask, on the mouth of this flask, okay, fix a rubber stopper. This is the rubber stopper with two holes. Okay, this is the rubber stopper. This rubber stopper. And this rubber stopper has two holes. One hole is this and one hole is this. This is one hole and this is one hole. So there are two holes in the rubber stopper. If you do not use rubber stopper, what will happen? The gas that is collected will escape out. Then through one hole pass a long jet tube. So through this one hole pass a long jet tube. This is long jet tube. So what is this? Jet tube. This is jet tube. Long Z tube is here, and through other hole, this hole, pass a dropper. This is the dropper with few drops of water. So pass this dropper through this hole and make sure that this dropper contains few drops of water. Then put the jet tube in the beaker containing blue litmus solution, and this is the beaker. This is the beaker which contains blue litmus solution. And one end of this jet tube is immersed inside this blue litmus solution and the other end is inside the round bottom flask. Then what happens? Let's see. Press the dropper. You need to press this dropper. It is seen that the blue litmus solution enters the jet tube. So what can be seen when you press this dropper? When you press this dropper, then you can see that this blue solution, okay, this blue litmus solution moves up. This blue litmus solution moves up, forming a fountain. Blue litmus solution enters the jet tube with a great force, forming a red fountain. So here is blue solution and you can see here the red fountain. Here is blue solution. Blue solution is going up and inside the round bottom flask you can see a red fountain. So why is this happening? What is the reason behind this? Let's see. As the water goes in the flask, this water, okay, this water through the dropper, once you press the dropper, what happens? The water gets into the flask. So once the water gets into the flask, HCl gas present in this flask, HCl, hydrogen chloride gas present in this flask, will get dissolved in this water, okay, which is just coming out from this dropper. Hydrogen chloride gas will be dissolved, and as we know that the liquid occupies less volume than vapor, okay. So water, ice, or water, liquid, okay, water in liquid form occupies less space than water in vapor form. Water in liquid form occupies less space than water in vapor form. So what happens is a lot of space, a lot of empty space will be created here. As a result, what happened? The pressure, the balance is disturbed. The pressure, this will become now the lower pressure, and this is at the higher pressure. So water moves from higher pressure to lower pressure. So why the lower pressure is created here? Because hydrogen chloride gas, which was occupying whole of this, is dissolved in water. As a result, water from the bath, okay, this bath moves up through this jet tube, and since this is blue litmus solution, and what is present here? Hydrochloric acid is present here when it mixes with water. When hydrogen chloride gas mixes with water, it forms hydrochloric acid, and hydrochloric acid turns blue litmus red. So you can see here the red fountain. So HCl gas present in the flask dissolves due to its high solubility, thereby lowering the pressure inside. So the pressure inside will be lower, the outside pressure being, so this pressure, the pressure here is higher and the pressure inside is lower because hydrogen chloride gas is dissolved in water. So the outside pressure being higher pushes the blue litmus solution turns red due to the acidic nature of hydrogen chloride gas. So why this is becoming red? Because of the acidic nature of hydrogen chloride gas. So due to the high solubility, hydrogen chloride gas fumes in moist air. Hydrogen chloride gas fumes in moist air, forming tiny droplets of hydrochloric acid. So what happens? Due to the high solubility of hydrogen chloride gas fumes in moist air, forming the tiny droplets. So you can here tiny droplets of hydrochloric acid will be formed because of its high solubility in presence of water. In water it is highly soluble. So yeah, the reason and everything is shown here. The pressure is shown. This you can go through. So this is the reason why this is the experiment that proves that HCl, hydrogen chloride gas, is highly soluble in water. Otherwise this blue litmus solution wouldn't have gone up, and there would not be any lower pressure zone. So since it is highly soluble, so the drop of water that is coming through this dropper, okay, in the water that is going through this dropper, in this water whole of the hydrogen chloride gas dissolves. As a result, there is lower pressure, and from this higher pressure blue litmus solution goes up and it becomes red. Why it is becoming red? Because of the acidic nature of hydrogen chloride gas. This much for today. Thank you.